Ever get that feeling, like you're always looking in the rearview mirror of time? You can clearly see last Tuesday's awkward Zoom meeting. The cringe is still palpable, right?
Uh,
But trying to picture what you'll be doing next Tuesday.
Feels like trying to grab smoke.
Exactly. You're definitely not alone. Today on the deep dive, we're plunging into why the past and future have this totally lopsided feel.
And it gets even weirder, doesn't it?
Oh, it does. Especially when you bring in the universe's birthday party and its potential retirement plan, things get seriously mind-bending.
That's right. We've got some fascinating material here, a collection of insights, really digging into the universe's origins and where it might all be heading.
So what's the mission for our listeners today?
Well, our mission today is to really get to grips with this idea of the arrow of time,
Okay.
how it's connected to the universe constantly stretching out, and this sometimes slippery concept of entropy.
Slippery is a good word for it.
We want those aha moments for you, definitely. But hopefully without your brain feeling like it's been through a, black hole simulator.
Okay, let's avoid the brain simulator feeling.
Yeah.
So let's start with the arrow that hits closest to home, the psychological one.
Right. Our own experience.
It's our own personal time teller, isn't it? That built-in sense that time only goes one way. And while our memories are full of yesterday's mishaps, like that time I accidentally put salt instead of sugar in my coffee. Shudder.
Ouch.
Oh.
Still remember that one clearly, yeah.
Vividly. But tomorrow's lottery numbers, still a complete mystery.
Precisely. And what's truly fascinating, I think, is linking this personal experience to something more, well, concrete. Like how computers saves information.
Okay, how does that work?
Picture a brand new hard drive. It's essentially a blank slate, right?
Yeah.
A state of disorder.
Yeah, nothing on it.
When you save a photo or a document, you're creating order. You're arranging things, the bits and bytes, on that drive to hold specific data.
Right, like organizing my spice rack, which, by the way, takes a surprising amount of focus.
Exactly. And that organizing, that act of creating order, it requires energy.
Okay.
When a computer writes data, some energy inevitably dissipates. It turns into heat.
Ah, right, computers get warm.
And that heat adds to the overall disorder, what we call entropy of the system, and, ultimately the universe itself.
So even me trying to remember what I had for lunch, was it that slightly questionable leftover pizza? Yes, it was. That mental retrieval process that takes energy too.
It requires energy, yes, and contributes in a tiny way to the total increase in disorder in the universe.
Wow.
The crucial thing to understand is that the direction in which the computer, and we assume your own mind, can access these past ordered states, these memories, is the very same direction in which the universe's total disorder is on the rise.
Okay, hold on. So my utter inability to recall what I'll be having for dinner next Thursday is fundamentally linked to the universe's tendency to get messier.
That's the connection, yeah.
That's properly weird to think about.
It's a profound connection we're exploring. It strongly suggests that our psychological arrow of time, how we experience time, is basically determined by this thermodynamic arrow.
Okay, so let's dive deeper into this thermodynamic arrow. This is the physics one, right?
Right. The famous second law.
It's all about things naturally becoming more chaotic over time. Yes. Like that coffee cup I mentioned, perfectly fine 1 second.
Smash.
Smash on the kitchen floor. And you never see those shards decide to spontaneously reassemble themselves and hop back onto the counter, good as new.
A perfect everyday illustration. The second law of thermodynamics essentially states that in an isolated system, total entropy or disorder tends to increase. It doesn't go down on its own.
So the intact cup is ordered.
Exactly. It represents a highly ordered state. The broken pieces, that's a state of significantly greater disorder.
Makes sense.
And think about it statistically. There are just vastly, vastly more ways for that cup to be broken into pieces than for it to be perfectly whole.
So it's just probability then? things fall apart because there are more ways to be apart than together.
That's the statistical basis, yes. It's like the universe has its own version of Murphy's Law, doesn't it?
Anything that can become a disorganized heap will become a disorganized heap. Suddenly, my overflowing laundry basket feels like a testament to fundamental physics.
Huh. In a sense, yes. A system that starts in an ordered state is overwhelmingly likely to move towards a more disordered one simply because there are so many more possible disordered arrangements available to it.
Okay, so we've got our psychological arrow pointing towards the past we can recall, tied to our thermodynamic arrow pointing towards increasing chaos. Now, what's this cosmological arrow all about? Sounds grand.
It operates on the grandest scale, really. The cosmological arrow of time is simply the direction in which the universe is expanding.
A whole universe getting bigger.
Exactly. Back in the 20th century, Edwin Hubble made that groundbreaking discovery. He saw that distant galaxies are moving away from us.
Right, the redshift.
Precisely. And the farther away they are, the faster they're receding.
Which means?
Well, it implies that if you run the clock backward, everything must have been much, much closer together in the past,
Squeezed together.
leading directly to the Big Bang Theory as our current understanding of the universe's origin point, a point of incredible density and heat.
So the universe started out super cramped and has been spreading out ever since. A bit like that yeast I accidentally added too much of to my bread dough last week. It just kept going.
A vivid image.
Yeah.
Yes. Now, let's think about how these arrows connect. We already touched on the psychological being tied to the thermodynamic.
Right. My memory works in the direction of increasing messiness.
Correct. The prevailing idea is that your psychological arrow is a direct result of the thermodynamic arrow.
Okay.
You experience time moving in the direction of increasing disorder because that's how your memories are formed
Yeah.
and how biological processes will proceed.
Makes sense. You can't really have a coherent memory forming in a system that's spontaneously becoming more ordered, can you?
Doesn't seem plausible, no. It'd be like the universe trying to untangle a bowl of spaghetti on its own. Doesn't happen.
Ah, good analogy.
And here's where it gets really interesting. This thermodynamic arrow, this constant march towards disorder, it appears to be deeply connected to the cosmological arrow, the expansion itself, especially when we consider, well, us, intelligent beings.
How so? What's the link there for us? Why does expansion matter for entropy in that way?
Well, consider the very beginning. Why was the universe in such a state of high order right after the Big Bang? That's the crucial question.
High order. You mean like not messy, smooth?
Very smooth, very uniform, very low entropy, relatively speaking. If the universe had started in a state of complete disorder, maximum entropy, basically a uniform, boring soup, it's incredibly difficult to imagine how the intricate structures we observe today could have ever formed.
You mean like galaxies, stars, planets?
Exactly. All of that requires gradients, differences, structure. You need that initial order to, well, disorder into something interesting.
So for disorder to increase to something interesting, there had to be some initial level of order to begin with.
Precisely. It's like you can't have a truly epic wardrobe malfunction unless you were wearing something reasonably put together to begin with.
Huh. Okay, I get that. So this leads to a massive question then.
A profound question, yes. Why wasn't the universe completely disordered from the start? Why this special ordered beginning?
And science has an answer.
Science is working on it. Some have contemplated the role of a creator in establishing this initial ordered state, setting the conditions just right. But, that's a question that currently lies outside the realm of what physics can test or confirm.
Right, that's more philosophical or theological territory.
Correct. Science focuses on finding physical explanations.
Okay, so the universe started ordered, expanded, and disorder increased. But what about the absolute beginning, like time zero? I've heard whispers of things like quantum gravity and this no boundary condition. Sounds a bit like science fiction.
It can sound that way, But these are serious scientific attempts to understand the universe's earliest moments, where our current theories, like general relativity, break down.
Because things were so extreme.
Exactly. At the incredibly high densities and energies of the very early universe. We need a theory of quantum gravity, something that combines gravity with quantum mechanics.
And how do we approach that?
One powerful approach involves Richard Feynman's sum over histories.
Sum over histories.
In essence, it considers all the possible paths, all the possible histories the universe could have taken to get from point A to point B. You sort of average them out quantum mechanically.
All of them. That sounds like a seriously complicated cosmic family tree.
It is computationally very demanding. To make these calculations more manageable, particularly around the Big Bang singularity, that point of infinite density our current theories predict,
Yeah.
physicists sometimes use a mathematical concept called imaginary time.
Imaginary time. Okay, now that definitely sounds like sci-fi, like something you'd encounter in a really vivid dream. Is it real?
Not real in the way you experience time, no. It's a mathematical trick, a tool. Think of it like rotating an axis on a graph. It helps to smooth out that problematic singularity at the beginning.
Okay, mathematical tool.
Using this framework, the no boundary condition was proposed by Stephen Hawking and Jim Hartle. It suggests that the universe is finite in its overall extent.
Finite, so it doesn't go on forever.
Finite in space and imaginary time, yes.
Yeah.
But crucially, it doesn't have a sharp edge or a starting point boundary in this imaginary time.
Like the surface of the Earth.
Exactly like the surface of the Earth. It's finite, you can travel all around it, but there's no point where you suddenly fall off an edge into nothingness. No boundary.
So the universe in imaginary time is kind of like a four-dimensional smooth ball. No starting point.
Analogously, yes. It doesn't have a creation point in that mathematical description. This condition suggests the universe began in a very smooth and relatively ordered state naturally without needing special setting up.
Ah, so that fits with the thermodynamic arrow needing an ordered start.
It fits beautifully. It provides a potential physical reason for that low entropy beginning.
But the universe isn't perfectly smooth now. We have galaxies and stuff.
Right. Even with this smooth beginning, tiny fluctuations, ripples predicted by quantum uncertainty, occurred. They were unavoidable.
Quantum jitters.
You'd call them that. And these tiny initial differences were then stretched by the universe's expansion, and gravity pulled matter together around the slightly denser spots, eventually forming the galaxies, stars, and all the structure we see today.
Fascinating. So a smooth start, mathematically speaking, leads to an expanding, lumpy universe where things get progressively more disorganized overall.
That's the picture, yeah.
But what about the grand finale? What if the universe stops its expansion one day and starts to contract? The big crunch idea.
That's a possibility people have considered.
Would time zero do a U-turn? Would the thermodynamic arrow reverse? Would my perpetually lost socks suddenly reappear in perfect pairs? A listener can dream, right?
Yeah, that's the question that has kept physicists up at night for quite some time. If the cosmological expansion were to reverse, would the thermodynamic arrow also reverse? Would disorder start to decrease?
It sounds like the plot of a particularly philosophical sci-fi movie. Broken cups reassembling.
Indeed. One might initially think, sort of intuitively, that a contracting phase would be like watching the expanding phase played backwards on a cosmic movie screen.
Yeah, everything just goes back the way it came. Order increases again.
That was the initial thought for some. However, our current understanding, particularly when we consider the implications of that no boundary condition.
Ah, the smooth beginning thing again.
Yes, it suggests otherwise. More detailed calculations considering things like black holes forming and merging during a collapse indicate that disorder would likely continue to increase even during a contraction phase.
Wait, really? So even if the universe starts shrinking again, the mess just keeps getting worse? My sock situation is still likely to remain a disaster?
The physics, as we currently understand it based on these models,
Mm.
suggests yes. Entropy would continue to rise. The arrows of time, both the psychological one you experience and the thermodynamic one governing disorder, would most likely not reverse.
Huh. So, no going back to a tidier universe, even if the whole thing collapses. That's surprisingly consistent, I guess, in a somewhat bleak way.
The universe, it seems, has a preferred direction for time, one dictated by this relentless increase of disorder, all stemming from that remarkably ordered beginning.
Okay. So, just to make sure I've got it straight for everyone listening, our personal sense of time moving forward, remembering the past, not the future,
The psychological arrow,
is tied to the universe constantly getting messier, more disordered.
the thermodynamic arrow, driven by the second law.
And the universe had to start out in a pretty organized, low entropy state for all this subsequent mess to even be possible, let alone for stars and us to form.
Correct. That initial condition is key.
And this ordered start might be explained naturally by ideas like the no boundary condition in quantum gravity.
It's a leading candidate, yes.
And crucially, even if the universe decides to shrink later on, the best bet is that the mess is just going to keep on increasing. No reverse gear for entropy.
That's a concise and pretty spot-on summary of our deep dive today.
It shows how even a seemingly simple question like, why does time move forward, leads us down these incredible rabbit holes.
To the very birth of the universe and its ultimate fate, yeah.
Yeah.
It connects the everyday to the cosmic.
Well, this has certainly been a lot to ponder. Definitely some aha moments, maybe a few, wait, what, moments
And
too.
hopefully more of the former.
So next time you stumble upon a broken plate, or maybe just notice the dust gathering, remember, it's not just clumsy hands or lazy housekeeping at play.
Yeah, it's physics in action.
It's a tiny piece of evidence pointing to the fundamental nature of time itself and our place in this expanding, ever more disordered universe.
Makes you wonder, doesn't it?
It really does. What other seemingly simple everyday observations might hold similar cosmic secrets? Maybe why toast always seems to land butter side down. Is there entropy in that?
Huh. Perhaps that's a deep dive for another time.